Hello. So this video is to accompany Notes 7.3b, which you are supposed to read on Friday, April 24th. Homework 7.3b is not until next week, which would be on April 27th, Monday. But at least read over the notes um, after you watch this video. So let's get to it. We're now trying to find various things. It could be area, it could be the length of dimension of a figure, but for this example, we're trying to find the area of the shaded part of the diagram. So the shaded part is inside of the circle, but outside of the rectangle. We would say that that the rectangle is inscribed inside this circle. So these types of problems take a little while because there are lots of steps. There are times when you could do the steps in different order, so you don't have to do it exactly the way that I am showing you. You'll be using a calculator because you'll get lots of weird numbers. We'll try to round any answer we get to the nearest tenth, which is 1 decimal place. All right, so our first step here, if I want to find the area of the shaded part, then I'm going to find the area of the rectangle in the middle. I will also find the area of the circle. That way, I can subtract the area of the circle minus the area of the rectangle to get the area of just the shaded part. So first, let's do an easy computation, which is to find the area of the rectangle. Or the area of a rectangle is just area equals length times width, or base times height. So I can just plug in the numbers that I have on the diagram here, which is 6 centimeters by 10 centimeters. So when I multiply that, I get an area of 60 square centimeters. Step 1 is complete. I now need to find the area of the circle, but in order to find the area of a circle, you need to use the formula area equals pi r squared, which means I need to know the radius of the circle, but I don't yet know the radius of the circle. So that's what we have to find next. The radius of the circle happens to be a diagonal of the rectangle. So we can use the Pythagorean theorem to find the length of the diagonal of the rectangle. And it will be in the shape of a squared plus b squared equals c squared, where a is 6 and b is 10. When I square those, I get 36 plus 100 equals c squared. 36 plus 100, of course, is 136. And when I square root both sides of that equation, I get about 11.7. Again, remember to round to the nearest tenth. So the length of the diagonal, the length of this segment, is about 11.7. So now I have a number I can deal with to determine the area of the circle. Now, the 11.7 is the diameter of the circle. And for area of a circle, we need the radius. But that just means we chop this number in half. So we'll use half of 11.7 to find the area of the circle. So the area of a circle, as I mentioned earlier, is a equals pi r squared. So we will use 3.14 for pi. We'll use 5.85 for the radius because the diameter was 11.7. Half of that is 5.85. Use a calculator and don't forget your order of operations. We must square the 5.85 first. Whatever that result is, multiply it by 3.14, and we get 107.5. That's the area of the circle. So we have to go back to the previous screen where we had the area of the rectangle is 60. So what I do is I take the area of the circle and subtract from it the area of the rectangle, which was 60. So the area of the shaded portion is 107.5, the area of the circle, minus 60, which is the area of the rectangle, and this gives us approximately 47.5. Now, I say approximately because 107.5 minus 60 is 47.5. However, the 107.5 is an approximation because we had to chop pi off at 2 decimal places. So this is approximately the area of the shaded part. All right, the last example on these notes, we have this shape, some type of semicircle here attached to a triangle. So we have to think about what our steps will be. Again, we're going to find the area of the shaded part, which is the entire thing. So we want to find the area of this whole shape. I can find the area of the triangle. That's easy enough. The area of a triangle is 1/2 base times height. But how am I going to find the area of the semicircle? Well, once I do find it, I will add it to the area of the triangle, and that's my answer. But to find the area of a semicircle, we would take half of the area of the full circle. To find the area of the full circle, I again need to know the radius of the circle, but I don't know it. I do see that I have what appears to be a diameter of the circle right here. So if I can find the length of that and take half of it, then I'll have the radius. All right, so our first step was to just use the area of a triangle formula to find the area of the triangle. So we plug in our base and our height, which are 5 and 8, respectively. So we get 1/2 5 times 8, which is 1/2 times 40, and half of 40 is 20. So now we know the area of the triangle. Next, I'm going to find the length of the hypotenuse of the right triangle, because the hypotenuse is the diameter of the circle or the semicircle. So I will use the Pythagorean theorem to say that 5 squared plus 8 squared equals c squared. Expanding that out, 5 squared is 25, 8 squared is 64. Add those together to get 89. Take the square root of both sides of the equation, and I get c is about 9.43. I could have just put 9.4, but for some reason I put 2 decimal places on this one. But that means that the diameter of this semicircle is 9.43. So remember, I need the radius, so I'm going to have to take half of this number in order to find the radius in the next step. Okay, so now let's find the area of the semicircle. Area is pi r squared. Now, keep something else in mind. The area of the full circle is pi r squared. Since this is half of a circle, we need to make it 1/2 of pi r squared. So we're just taking the area of a circle and then multiplying it by 1/2, or taking a half of it. The radius is 4.715, which is half of the diameter that we found in the previous step. So just take a calculator and do 9.43 divided by 2, and you get 4.715. Remember your order of operations. The first thing we do is we square the 4.715, and that gives us 22.23. 22.23 times pi, and then times 1/2, gives us our area of the semicircle, which is about 34.9 square millimeters. So now we know the area of the semicircle and the area of the triangle. We just have to add them together. So the last step, I add together the two areas that I already found. So I take the 34.9 square millimeters that we just found for the area of the semicircle and add it to 20 millimeters squared, which was the area of the triangle. So when I add those together, I get 54.9 square millimeters. And just a small thing, but this equal sign should be a squiggly equal sign because it's approximately equal. So let's take a look at the assignment, even though you're not supposed to actually do it until Monday the 27th, but we'll take a look at it anyway. Actually, we won't. We'll hold off until next week on that. In summary, to end this video, you need to use several tools to complete these problems, and you'll see that when we do the homework assignment next week, there are only 2 problems because they take a little bit of time to do. You might be using the Pythagorean Theorem, so you have to know how to do that. You're going to be finding areas of rectangles, squares. You'll be finding the area of triangles, as well as circles or semicircles. And finally, you'll be reasoning because you have to come up with a list of steps to come up with your solution. So all of these things working together, you got a lot of tools in the toolbox that you have to use. And I'm here to help you. So if you have any questions, send me a message on Remind and I'm happy to assist you. So if you like this video, smash the like button, subscribe, or not. Hope you guys are doing well. Stay safe. See you next time.